Okay, so we're going to introduce a new concept in this video called a logarithm. And before I get to actually what it is and how it's used and stuff, I want to give you an example of why you even care about them and what they're good for. Say we had the equation 3 to the x power equals 12. There really isn't a good way of solving this by hand with what we already know in our our math abilities. You can't go dividing by 3 or something like that. The answer is not 4, because 3 to the 4th power is 81. The best we can do, really, is say, okay, the answer is somewhere between 2 and 3. Because if you do 3 squared, you get 9. If you do 3 to the 3rd, you get 27. And it's probably closer to 2 than it is to 3. But in terms of the actual decimal, all you'd really be able to do is take your calculator and just start typing in things until you get close. That's not a great strategy, but it's the best we have right now. We need a way where we can get the actual exact answer to problems like the one above. So a log is going to be very helpful in solving for equations when your variable is in the exponent. That's what it's going to be good for. Before we can get there though, and before we can do that, we need to learn a few basic properties about logs first. The big rule, the one that we're going to be using very regularly in this class, is written right here in red. If you have something like this with a log in it, logs have a base, they have a number we're actually taking the log of, and then they have an answer. This red and this red are the same thing right here. You would pronounce the guy on the left log base b of y. And the way that we convert these right here, we take the base, we raise it to the answer power, and we set it equal to the inside. So what we did is we did b to the x power equals y, and that's how we wrote our exponential equation over here. Right now, logs don't make a lot of sense to us because they're new, we've never seen them before. So we're going to want to practice converting back and forth into exponentials because those typically make a little more sense to us. As we get along though, you become a lot more comfortable with logarithmic form as well. So, to really kind of drive this home right here, I have like a little hand motion that I use when I'm converting logs into exponentials. I want you guys to follow along on your paper. So when you write this down, actually take your index finger here. It's going to be this number to this power equals this. And there's a little sound effect that goes with it. It's really cool. It goes like this. Just like that. I'll do it in class too so you guys will see it again. But we're going to take this number to this power equals that answer. And that is how we convert them. So let's look at some examples now. You guys can get a sense of what we're even really doing here. A problem may ask you to write something in exponential form. So I gave it to you with a log in it, and I asked, okay, rewrite this so it's an exponential. So my first one right here, if I use my little hand motion here, it's going to be 3 to the 2nd power equals 9. That's what we're looking at there. And that does in fact make sense because 3 to the 2nd power does equal 9, so we're good. This is the exponential form. It means the same thing as the black, it's just a different way of writing it. For my second problem here, if it bothers you that the 1/2 is over here, because we're used to the equals being on the right, just rewrite it. So it's the same thing as a 1/2 on this side, where you do this number to this power equals that. So when we go and do that, we get 16 to the 1/2 equals 4. And that does make sense if you remember, okay, a 1/2 power is the same thing as a square root. So yeah, that checks out. Sometimes I may give you random letters on a logarithm, so you can't test like these two to make sure you did it right. But all you can do is just the same motion here. This number to this power equals that. So we're looking at u to the 7th power equals v. Now, we may also want to take an exponential equation and go back into a logarithm with it. So we're going to rewrite it as a log. This can be a tiny bit trickier for kids at times, just kind of doing the same thing though, but in reverse. So I know that when I start doing that motion here, I always start out with the number that goes right here is underneath the log. So the number under the exponent goes under the log here. The answer to my problem is the exponents, and then the answer to my new problem is the exponent, and then this guy right here goes within my log. I don't think I explained that all that well, but what I always do when I finish these is I test them just to make sure I did it right. If you test it out here, you get 5 to the 2nd equals 25, and it does in fact match. You should always test them to be sure. On my next one here, the number under the exponent goes under the log, that's your base. We're going to put the exponent as our answer, and then the answer in the original is the inside. And always test yourself, 8 to the 1/3 equals 2, that does check out. Last one here, we're looking at log base u of 12 equals v, testing it to be sure, and it does in fact match up. In later videos, we'll learn things we can actually do to solve problems. Here we're just learning how to convert between two forms.